Today is 10th of November 2025. First discrete time Markov chain. They have m by m matrix and transitional probabilities defined. We introduced the gambling's formula, gambler's rule. So basically, from here you can go and this. There will be end state, which is absorbing state. Whether you disrupt it or whether you won the game, then it will be finished. The absorbing state, there will be only incoming flow, not outgoing flow, and there's inflow and outflow equation. And so basically this is the definition of Markov process, and transition probability is defined like this. And when we analyze Markov chain, what we should do is, how many classes do we have? Like if state I and J communicate each other, then it's just one class. And there's a period whether it goes back in one state, then this is aperiodic. And if it goes to here and goes back, this is period 2, because 1, 2. We calculated it by using GCD, general common divisor. So every state GCD is what we define, and whether we are classifying whether it is recurrent or transient or absorbing. So transient is basically PII 1 to PII infinite, or of the sum is smaller than 1, so it may not come back again. That's what transient space is talking about. But not every state can be transient. Basically, there should be some recurrent state who receive it. An absorbing state is very special case of recurrent state, and there's very useful formula, which is P A intersect B. Conditioning by C is same as P A conditioning by B intersection C. P multiplied by P probability of B conditioning by C. So when can we use it? Such as, let's calculate such as f2, 1, which is probability of 2 to 1 infinity. So probability of state from 2 to 1 in infinite step. Then we will probably calculate it by because this is in this case like there's state 1 to 3, state 1 to 3. We can we can write it down by x infinity is 1 and x0 is 2. Then we can split it into 3, which is x infinity is 1 and x0 is 2, but it could be x1 is 1 or x1 is 2 or x1 is 3. And there will be conditioning. Then we can write it down differently, which is px infinite equals to 1 when x1 is 1 and x infinite is like this, when x1 is 1 and x0 is 2 and x1 is 1 and x0 is 2, multiply by each other. Then what we can easily calculate is p2, 1 is same as 1. Yeah, there's corresponding probability. And f2, 1 differs the definition of x0 is 2, and when it is infinity, this is basically from 2 to 1, and multiply by 1/2. Yeah, like this. Thank you.